Hi, my name is January Gilbert Malik, and for this video, I will discuss about the N-type and P-type semiconductor used in a computer system transistor. Before that, let me show you some terminologies that we'll encounter on this lesson. So first, what is a transistor? A transistor is a device used to amplify its electrical input. It is also a binary switch and the fundamental building block of computer circuitry. It either prevents or allows current to flow through. So basically, the concept of transistor in a digital circuit is an on and off switch that is conductive when pulsed with electricity. The active part of a transistor is made of silicon or some other semiconductor material that can change its electrical state when pulsed. Before I talk about semiconductor, let me differentiate the physiology of conductor and semiconductor's atom. Most conductors have just one electron in the valence shell, as seen on the figure, while semiconductors, on the other hand, typically have 4 electrons in their valence shell. So now, what is a semiconductor? Semiconductor is used extensively in electronic circuits. It is also material that conducts current, but only partly. Therefore, its conductivity is somewhere between an insulator and a conductor. Semiconductors are crystals made of certain materials, most commonly silicon. But before we understand about how semiconductor works, we must first understand how electrons are organized in an atom. The electrons in an atom are organized in layers. These layers are called shells. The outermost shell is called the valence shell. If the electrons of this shell bind with the electrons of the neighboring atom, it will form a covalent bond. In this figure, each circle represents a silicon atom, and the lines between the atoms represent the shared electrons. Each of the 4 valence electrons in each silicon atom is shared with one neighboring silicon atom. With this, each silicon atom is bonded with 4 other silicon atoms. Although pure silicon crystals are not useful electronically, we can introduce a small amounts of other elements into a crystal, and the crystal starts to conduct in an interesting way. The process of deliberately introducing other elements into crystals is called doping, and the element introduced by doping is called a dopant. By carefully controlling the doping process and the dopants that are used, silicon crystals can transform into one of 2 distinct types of conductors. Those 2 distinct types are N-type, which are created when the dopant is an element that has 5 electrons in its valence layer, and P-type happens when the dopant, such as boron, has only 3 electrons in the valence shell. We will first discuss about the N-type semiconductor. And for this semiconductor, phosphorus is commonly used as a dopant. The phosphorus atoms join right in the crystal structure of the silicon, each one bonding with 4 adjacent silicon atoms just like a silicon atom would. Since the phosphorus atom has 5 electrons in its valence shell, but only 4 of them are bonded to adjacent atoms, the 5th valence electron is left hanging out with nothing to bond to. Therefore, they are free to move about. These extra valence electrons in the phosphorus atoms will start to behave like the single valence electrons in a regular conductor such as copper. Because this type of semiconductor has extra electrons, which is negatively charged, it's called an N-type semiconductor. Next is the P-type semiconductor, and as discussed earlier, boron is commonly used as a dopant for this semiconductor. Since boron has only 3 electrons to offer, a hole is created. The hole behaves like a positive charge, so semiconductors doped in this way are called P-type semiconductors. Like a positive charge, holes attract electrons. But when an electron moves into a hole, the electron leaves a new hole at its previous location. Thus, in a P-type semiconductor, holes are constantly moving around within the crystal as electrons constantly try to fill them up. Therefore, when voltage is applied to either an N-type or P-type semiconductor, current flows for the same reason that it flows in a regular conductor. The negative side of the voltage pushes electrons and the positive side pulls them. The result is that the random electron and hole movement that's always present in the same conductor becomes organized in one direction, creating a measurable electric current. And that's it for this video. I hope you guys learned and understand the chemistry behind the computer transistor. Thank you guys for watching. I'll see you again next time.